Everybody. Yeah, good evening, everybody. Welcome to the ECBA webinar, already the 10th in a range, and we're very pleased today to have Dr. Klaus Thuneke here, who will take us by the hand and lead us through the developing country of future fuels for agriculture. I'm from the Netherlands, so that means that we have a lot of agriculture, but we also have a government which tries to move the other way. So for me personally, it's very interesting to have a look at this webinar. So what about the ECBA? Because there's an ECBA webinar, and the ECBA is the European Countries Biologists Association. It's an association of associations, which means that not many individual biologists are a member, but the biological institutes of Europe are a member. And here we try as good as we can to have a European sound available on biological issues. And it goes two ways. It goes towards the biologists and from the biologists to society. And one of the things which I am always keen on, or what I think is very important, every species, every academic species has a particular way to behave, as we all know. And biologists are not always at the front or speaking out loud. Many other academic species are much better doing it than biologists. And to me, I think we've had the privilege of drinking from this gorgeous academic well where biology is in, so we have all this knowledge, but we don't have. But we should also then have our responsibility and act on the information we have received. So as a biologist, I would say the thing is to be proud as a biologist, because that allows you to speak out. But what we have to talk about is not such a happy message, because we are proud but not happy to be a biologist, because we see all kinds of things coming.
Thank you.
Now over to Simon.
I'm going to say a few things about the Synopsis project, because this is a Synopsis webinar tonight as well. The Synopsis project, so we are setting up a Erasmus Plus School Heads and Teacher Training Academy on teaching for sustainability citizenship. And sustainability citizenship involves actively engaging in environmental, social, and economic sustainability efforts. So this is going away from a passive recipient. We do emphasize that participation, advocacy, and informed decision-making is more important than passive support. And this is why we are doing this webinar series also, to bring people together and learn from each other. And it's not only about awareness, because I think this is getting depressing for a lot of people, but we need to find ways how to solve the issues we have. So a sustainability citizen recognizes the interconnectedness of global systems and takes responsibility for contributing to a positive change. And here are a few faces of the Synopsis Consortium. This was during a meeting, and we are from 7 different countries in the European Union, and we are 10 different organizations. We do have experience in a lot of different fields. And if you are a teacher, it would greatly benefit our project if you could scan this QR code and quickly fill out the survey we have prepared for you. And now I'm looking forward to Klaus' talk. Thanks, Klaus, for accepting my invitation. We're going to hear your talk about future fuels for agriculture. And you are a senior research associate and deputy head of the Department of Renewable Fuels and Materials at the Competence Center for Renewable Resources in Straubing, Germany. You are involved in research and evaluation of climate-friendly and sustainable fuel alternatives and propulsion systems for agricultural mobile machinery. The focus is on technical, but also economic, ecological, and social aspects. In the field of renewable materials, your team is developing sprayable and biodegradable renewable covering materials for plastic film replacement in agriculture. And now I'm really looking forward to your talk, and the floor is yours.
Thank you, Simon. So I tried to. So, okay. You probably see the first slide, yeah.
Yeah, we do.
Okay. Good
To all
evening.
participants, sorry, one more remark. You may use the F&A function of Zoom to address all your questions to Klaus already during the talk if you like, but we will have a big questions and answer Q&A session in the very end. Thank you.
So thank you, Simon, for your introduction, and hello, everybody. Future fuels for agriculture is the topic of my presentation. My name is Klaus Thuneke, and I work for the Technologie und Förderzentrum, which is located in Straubing. Straubing is in the southeast of Germany, in Lower Bavaria, and Straubing is a small city with 50,000 inhabitants. It lies on the banks of the river Danube, just on the slopes of the Bavarian forest. And Straubing and the surrounding calls itself the region of renewable resources. And this is mainly due to the Center of Excellence for Renewable Resources, which was established, which was founded 25 years ago. So Center of Excellence for Renewable Resources is the name of the roof of 3 independent institutions. One is the Technical University of Munich, Campus Straubing for biotechnology and sustainability. On the left-hand side, you see it, they're doing basic research and academic teaching. In the middle, you see our institutions, the Technology and Support Center. We do more applied research and demonstration of new technologies. And on the right-hand side, you see Carmen, which is a non-profit organization. It's an association with about 70 members. They are in charge for the market implementation of new technology, of new products based on renewable resources. They're doing conferences and promotion. Just one slide to the Technical University Munich Campus Straubing. They run bachelor and master degree courses in bioeconomy, in chemical biotechnology and sustainable management and technology, and a couple of master degree courses in biomass technology and sustainable energy and processes. So that's all the same campus where we are, but it's of course a different institution. Our institution in the middle, Technology and Support Center, is actually an institution of the Bavarian State Ministry of Food, Agriculture, Forestry and Tourism. Very long name for a ministry. And our mission is to support the production and utilization of biomass for energy and industry use. So we're doing that by applied research, as I said, by demonstration and consulting activities. And we run a museum. You see on the picture on the top on the right, it's a museum for sustainability and climate protection called Navareum. All in all, we have slightly more than 100 staff members, and our research work is done in 4 research departments. One department is renewable resources, crops and material cycles. So they look at new plants which are not grown already in our areas in Europe or in Germany, which could be used as alternative raw material. Then the research department of solid biofuels, they usually look at solid biofuels, wood, logwoods, but also chips or pellets. And they do a lot of research in terms of quality, but also in terms of the way they can be burned in furnaces, as you see in the middle picture on the bottom. The department I am from is the Renewable Fuels and Materials Department. I will say that some words after this slide. And we have a 4th department which is doing system evaluation of renewable resources, which is mainly eco-balancing, greenhouse gas balances and things like that, because all of this new technology, of this renewable resources have to be sustainable in a way, and to prove that, to calculate all the important impact, we have one special research department who is doing these kind of balances. In our new department, or in our research department, renewable fuels and materials, our key activities is the evaluation of alternative fuels, especially for agriculture and forestry. We're doing quality analysis of renewable fuels in a laboratory, which you see on the picture on the top, like the ignition behavior, one important criteria for fuel use. We work especially on the operation and emission behavior of agricultural machinery driven by various fuels at our test stand in the middle picture on the right, and in the field as well. For many years, we support now our state-owned farms, which belong to our ministry, during their transformation to climate-friendly propulsion systems. Due to the Bavarian climate protection law, the state administration has to be climate neutral by 2028. And especially the agricultural or the farms, the state-owned farms, have the problems or the challenge that even the tractors and all the agricultural machinery has to switch from diesel to any renewable new fuel. And last but not least, Simon said it in the introduction, we are also developing renewable two-component covering materials for agricultural and horticultural applications. They are sprayable, they are tearing, they get solid once they were put on the product, and finally they are biodegradable after the lifetime. So these cover materials, for example, for silage heaps, instead of the plastic foils, you can spray there, and you could take the material, the cover material, and take it into the biogas plant as well, or put it as a feed for the cows. And one other application for such covering materials is a mulching material, which can be used in vineyards or in orchards to depress or for weed control. But the topic today are future fuels for agriculture. This will be the outline for the next hour or so. I will give you an introduction and motivation. Why are we working on future fuels for agriculture? Why do we need any alternative for diesel fuel? Then I will display and show you the different possible discussed alternative fuels for agriculture applications. I will give you an overview about these options. Then I want to point out some selected properties and compare them each other in order to see which options, which alternative fuels might be suitable for a special application, for a special work, for a special machine. After that, I will give you a scenario which was developed from experts in a special board, agricultural board, who were thinking about how could the transformation until 2030 and 2045, how could that happen to go from diesel to alternative fuels. After that, I will give you some examples of possible measures for action to reach that goal. And finally, I will end up with a summary. But first, now to the introduction. The current situation is that the whole energy supply for agricultural mobile machine is currently exclusively based on fossil diesel fuel. So we have only the numbers for Germany. but I think in other countries it's not that different. Maybe the figures are different, but the situation itself is not that much different. So all in all, we use every year 1.9 billion liters of diesel fuel, and that corresponds to about 66 petajoule per year. So that's the amount of diesel fuel we are using in agriculture every year. And these diesel fuel is split into different ways of using it, like or different agricultural works. Like it's almost it's almost divided in 4 quarters. So if you look on the top left, you see the livestock farming, which needs about 1/4 of this diesel fuel, and which is responsible for 1.1 million tons CO2 equivalent emissions per year. On the right-hand side, you see a light field work, which is like spraying or seeding, which is also about 1/4 of the diesel demand in German agriculture. On the bottom right-hand side, you see medium field work. And on the left-hand side, on the bottom, you see heavy field work. So heavy field work is like plowing or big harvesting machinery, which are responsible also for about 1/4 of the diesel demand, and also 1/4 of the exhaust, sorry, not exhaust, for the climate emissions of the German agriculture. So one pre-consumption is that we need a reliable energy supply is important for agriculture to secure food security. So 3 years ago in the Ukraine, our agricultural minister, or former agricultural minister, went there and visited farmers, and they had the problem that on the one hand, the storing capacities for their harvested crops was not enough because they couldn't sell it. And he said he would only need a large rapeseed press and he could make biodiesel from it. And that's one problem. And another problem is that diesel was becoming scarce due to the war activities in the country. And without diesel, no combine harvester will run. So without fuel, you can't really do any agriculture because it's all dependent on big machinery and on a reliable energy carrier and a reliable fuel. It is not only during war, also in Argentina, I translated it, there was at the same time a shortage of diesel fuel, and this was also because of economic crisis. And here the wheat sowing was at risk, and the harvesting work has come to a standstill because there was not enough diesel fuel available. We don't really have these problems aware at the moment because we think diesel fuel will never end. But if you look at secure and security of supply of food, you also have to think about securing the supply of fuel for agriculture. The climate protection target we have in the sector agriculture is another problem in combination with diesel fuel. At the moment, we have about, or 22 was it, 62 million tons of CO2 equivalent emissions from the agricultural sector, which you also see on the right-hand side in the diagram, in the graph. The green part of the graph is fermentation, which means it's livestock farming. The dark blue part of the column is fertilizing. The light blue color is assigned to the emissions of agricultural soils. There are some other minor emission sources, And on the top, the gray one is assigned to or allocated for energy. About 10% of the whole emissions are related to energy, which you could say is not very much, but when you look how easy it is to reduce greenhouse gas emissions, they are probably the low-hanging fruits, because if you want to reduce greenhouse gas emissions from the ground, from the soil, it's nearly impossible. Otherwise, you have to reduce agricultural activities. Or also, if you look at the livestock farming, you have to reduce the number of livestock in order to get a good reduction of greenhouse gas emissions. The aim or the target of the sector agriculture in Germany is 56 million tons by 2030. And if we replace all the diesel fuel of this gray part of the column with renewable fuels, we could reach exactly this target in the year 2030. And no one has to forget the climate neutrality by 2045 is already legal. So the use of diesel fuel carries risks regarding the supply security of food and also the conflicts with climate protection goals. And this is why we have to leave the area or the era of fossil diesel. But no worries, there are better alternatives anyway. And now we can have a look at these alternative fuel options for agriculture. I will give you an overview about these options. In this slide, you just see that there are many pathways from different renewable resources you can make by different conversion technology, different products. So the green on the top are based on sustainable biomass, which could be either cultivated crops, which could be residues and waste, or which could be, of course, also being algae. On the bottom, the blue ones are the renewable resource based on renewable electricity, on wind, solar, and water. And the processes can be quite vary a lot. So we have a lot of choices like biochemical conversion, physicochemical conversion, thermochemical conversion, and electrochemical conversion. It can be linked with each other. There are synergetic effects of different pathways. We produce often additional products, co-products. So as you see, all these processes are linked together, and I don't want to go in detail in all these conversion technologies, but there are many options available in order to get the products which are displayed on the right-hand side, which could be food or fodder, which is often the main reason, the main target for agricultural activity. But you can also get a lot of different fuel possibilities, fuel options like bioethanol, biodiesel, HVO, methane, synthetic fuels, synthetic chemicals, and also basic chemicals. So all these processes are somehow related together, and there are many options. So, but what are the best options? That's probably you want to know. For agriculture, we have to keep in mind that we have different type of machinery. We have different types of works we have to do with this machinery. We have like very small loaders, usually are operated on the farm themselves. We have tractors. We have also big harvesters. self-propelled machines, and we have now any of them are usually driven with diesel, and we have to find a good solution for all these different applications and all these different needs which are in agriculture. So at the next slides, I would show you clockwise the biomass-based alternatives like plant oil fuel, like biodiesel, like biomethane, and HVO or BTL. And after that, the synthetic fuels, which are not biomass-based, the so-called e-fuels or power-to-X hydrogen, either in combustion engines or in the fuel cell, and also electric power and battery. So let's start with the biomass-based alternatives. Start with plant oil fuel or rapeseed oil fuel. This fuel is at least common for 30, 40 years. It has a national standard, DIN 51603 and DIN 51605. The feedstock here in Central Europe is mostly rapeseed oil, but it can be also other oil plants, especially when you look at South Europe, probably more sunflower will be take a major share. So that'll be one of the options. The production technology is established, and it's also possible to make a self-supply in decentralized oil mills. The density of the fuel of the rapeseed is very high, comparable to diesel. It's rapidly biodegradable if it comes or if it gets into the environment, and it's not a hazardous substance at all. The storage and refueling is very easy at the farm. The costs of investment for refueling stations is low, and one problem is that there are no public gas stations where you can get rapeseed oil fuel or plant oil fuel in pure form. The fuel costs are moderate. You can produce it inland, so security of supply is okay. The quality or the properties are a little bit different from diesel fuel. The viscosity is higher, so you need to do some adaptation on the machines. Currently, there are no factory approvals for tractors which are suitable for using pure plant oil, but there are many some test tractors in trials, in field trials, like from John Deere. And we have here also companies, workshops which do retrofitting, a conversion of conventional diesel tractors to the use of pure rapeseed oil or other oil plants. Some more words to rapeseed oil processing. The growing rapeseed is Germany. It's grown anyway on 1 to 1.5 million hectares, which relates about to a maximum of 9% of our agricultural land. The rapeseed is a very valuable fruit for to open up or to get more diversity on the agricultural production. The oil yields are quite high, 1.5 tons per hectare. And as I said just before, you can process it quite easily, either in industrial oil mills and big industrial oil mills. They do a mechanical and solvent extraction of the oil from the oilseed. But you can also produce rapeseed oil in decentral oil mills, which you see on the picture on the bottom. It's like a garage, and the far side, the green one, is the screw press, where the seed is separated into oil and press cake. And on the left-hand side, the blue is a chamber filter press, which is used for clarifying the fresh pressed oil. And on the right-hand side, you see security filters, which are also to guarantee the quality which is needed and required for using it, either for nutrition, for feeding, for lubrication or coating, also for chemical industry or for fuel use. You see, oil plants are usually a multi-purpose plant, so you can use the oil for many different options, and which is good because in case you have a low oil yield, for example, 1 year, you have still enough oil seed to get at least the nutrition sector totally the demand or the supply for the nutrition sector. So you can shift between the different sectors because it's all the same sort of quality of oil. Here again, a picture from 1 hectare rapeseed. In the middle, you get about 3.8 tons of seeds. And from the seeds, 1/3 is about rapeseed oil, which you can use for 5 hectares of field work in tractors. And on top, you get about 2/3 or 2.5 tons of breast cakes, which is used as a protein-rich and very valuable feed for especially cattle, especially cows, which gives milk, and also manure, which can also be used in biogas plants at the end. And apart from the seeds, you can get, because the rapeseed is flowering just at the moment, it's flowering seeds probably anywhere on the landscape. You get honey, about 40 kilograms per hectare. You get straw and stubbles that are usually stay on the field or on the ground, which increases the fertility of the soil. So if you only look at rapeseed oil from that field, it is thought too short. So you have to look at the whole plant and the whole options which can be done, and which how it fits in a rotation crop system in the agricultural practice. As I said, rapeseed is not the only oil plant. The good thing is that worldwide there are so many different oil plants which can be used, either some for food, some not for food, but for technical reason and especially for energy reason, like sunflower, linseed, soybean, hemp, Abyssinian mustard, cottonseed, jatropha, moringa. So there's an endless list of possible oil plants which can be used for energy and for fuel use. So the next fuel is biodiesel, or farm fatty ethyl methyl ester, also named. The feedstocks can be plant oils and, as we see just, and also used cooking oils, so waste oils. The production technology in industrial scale is established. We have many of these trans-esterification plants in Germany, but all over Europe. Usually biodiesel now is blended to fossil diesel in a share of up to 7–10%, depending on the country. But you can also use it as a pure fuel, and it was used maybe 10–15 years ago. It has a high energy density as well. It has only the water hazard class 1, diesel has 2, and all in all, it's assigned to a not hazardous substance. The storage and refueling is like rapeseed, simple, low investment costs, however, there are no available public gas stations where you get pure biodiesel. This is a bit of a problem, so you have to get the refueling stations on farm. The fuel costs are also moderate, and here the factory approvals are still available for older tractors. And now it's getting more and more important again. There are some factory approvals for commercial vehicles, and we are doing current field tests with the company Klaus. And you might get partly individual approvals for biodiesel 100%. The next fuel I will talk about is biomethane. It's a gaseous fuel with a very broad feedstock base. It could be waste, slurry, manure, renewable resources. So many of these feedstock can be fermented in a biogas plant, and the biogas production is also established. But if you want to use it as fuel in a conventional engine, you have to do upgrading to bio-CNG. So it will get the same quality as natural gas. But here you need some plants to do the upgrading. It is also realized, so it's not a big thing, but the plants are a bit more expensive, and it's not for every little farm. The energy density is lower if you compress it to 200 bars. It's still about 1/4 of the diesel energy density, which means the tanks, the storage capacity on the tractor has to be bigger in order to get the same range. Of course, there's no danger to soil and water from this gas. And the farm refueling stations are costly, and we have about 700 public filling stations. They are quite expensive, so it's not easy to build up a private or a on-farm filling station that easily. The fuel costs are moderate again, and there are some tractors which are series produced already available on the market, like from New Holland. And there are many, many concepts which were presented so far, many prototypes from different companies. So that's the gaseous form of biomethane. You can also do a liquid form of biomethane. Here the feedstock is the same as the gaseous one, but you have to do a liquefaction of the biomethane by cooling it down to -162 degrees centigrade. So you get a higher energy density, so you can have smaller storage capacities on the tractor. But on the other hand, you have to cool it down, which needs energy, which demands energy. And on the tank, you need active cooling or emptying the tank if you leave the tractor for a longer time standing without work. And especially in agriculture, it could happen that there are 2-3 weeks that there is no work. And so we don't think it is very, very suitable for agricultural application. It is good for trucks, for example, on road, which run every day on big motorways, but it's probably not the best idea for agricultural applications. We have some methane upgrading plants. They are already available. The energy density is higher than for bio-CNG for the gaseous form, but still about half of that of diesel. So you still need more storage capacity, or you have to refuel more frequently. Altogether, we have 169 public filling stations. New construction of public filling stations is also very expensive, starting from 1 million euros about. And there is one tractor from New Holland as well, which is a serious prototype. The technology on the tractor is almost the same, apart from the storage capacity and the storage cooling. The last biomass-based fuel I will talk here is the HVO. It belongs to the paraffinic diesel fuels. It is called hydrotreated vegetable oils. For hydrotreated vegetable, for HVO, we have also brought feedstock base. It could be waste, slurry, manure, but it could also be renewable resources. But you need additionally hydrogen. So it's a hydrotreated process where you need hydrogen. And the production usually takes place in a few large scale plants. not in Germany, only in Finland and in the Netherlands, in Rotterdam. There is a big plant in Italy, as far as I know, and also in Singapore. So there's a few big refineries where these products can be produced, but it's not really, easily to produce it in a small scale. The energy density is also very high, also close to diesel fuel. It is the very big positive thing is that it is mostly compatible with the conventional diesel engines. So you can put it in conventional diesel engines, and most, especially in the newer ones, there is not a big technical problem. The storage and refueling is also very simple. The investment costs are the same as for biodiesel and pure vegetable oil. So far, it is available at, I think it is a little bit more now because they're just about getting more and more public filling station who offer HVO for the use. The fuel costs are moderate, but there are competitive markets very strong, like in aviation. Especially in the next years, aviation has compulsory shares of renewable fuels. And the only really possible alternative fuel is HVO or paraffinic diesel fuel. So we think that there will be more demand from various markets, which could be competitive and which could be a problem that there will not be enough fuel for all the applications we would appreciate. There are many factory approvals from, I think, almost any agricultural supplier now. So they're really a state of the art to be used in conventional diesel engines or in new machinery, but also in machinery that are already in use. So these were the fuels biomass-based, the green ones. Now I'm switch over to the synthetic fuels, starting with the production of e-fuels. I just want to explain you a little bit the production process. So you need renewable energy, here displayed with some wind energy. They make power, and the power you can use directly in an electric engine. Of course, you have to store it somewhere in between in a battery or something, but this is probably the straight way to use it directly in an electric engine. You can use the power for electrolysis with water, and then you get hydrogen and oxygen. But the wanted thing is hydrogen. The hydrogen you can also use directly in fuel cells. In the fuel cells, the hydrogen is used to make electricity, to make power out of it, and the machine itself is driven by electric engines. But it is like a kind of storage of electrical power, this hydrogen. And you can use the hydrogen also directly in a combustion engine. But that's a way some are going, but the most of the technology, the pathways are going over the fuel cell. If you don't want to use it directly, hydrogen, you can make a synthesis together with CO2, with carbon dioxide, and some upgrading and refining steps, and then you can make power to gas fuels out of it. For example, synthetic methane, like we were talking before, biomethane, which was made out of biomass over the biogas station. And here you can make a synthetic methane with almost the same or even totally the same characteristics of the fuel. And you can make liquid fuels out of it, which can be used in combustion engines or also for flight propulsion. So the electrical power and the synthetic fuels are depending on the way how much steps are in between. And the further the steps, the easier they are to use and to store, but the more you lose energy on the way due to these processes. So the efficiency at the end will decrease with every step. That's why many favor the application of electric engines and using the power directly, like in passenger cars, but also for options in the agricultural. But I will tell you a little bit later about that. So these e-fuels that are from the right-hand side, I will start from the right-hand side. The liquid ones, here the raw materials are green hydrogen and CO2. The green hydrogen is made out of renewable electricity, mainly from wind and sun. But you also need fresh water. People don't think about that often. For 10 kilograms, with 10 kilograms of fresh water, you get 1 kilogram of hydrogen. This is probably not the big problem in Central and Northern Europe, but when you look where the most or the main renewable electricity or the highest solarization is the main renewable electricity can be produced, that's more in the southern part of the world and near the equator. For example, in arid regions. And here you have to think about seawater desalination if you want to produce hydrogen, for example, in the desert. The CO2, where is the CO2 coming from? It can be from biomass over the biogas process. And when you do the upgrading to biomethane, CO2 is available for this process. Also bioethanol plants or just any combustion process. You have CO2 as a point source because it is more concentrated rather than in the ambient air. But it's also possible to use the ambient or the CO2 from the ambient air by direct air capture. And that's called diffuse CO2 source. But it's really a high effort. You need a lot of air to get at least a little amount of CO2 for this process out of the ambient air. The production processes, power to X and power to liquid, are at the moment at a pilot scale. The industrial plants are planned worldwide, but the capacities are still very, very low. So even if it's a very good fuel, it can be used as HVO in many, many applications in the engine, which is good for climate protection. It is very expensive and it's very high effort to produce it, and you have to do a lot of investment to set up these plants. The fuel costs are very high because it's so a costly process. But however, the properties and the handling, the applications are very, very positive and similar to hydrotreated vegetable oils. Let's come to hydrogen. The technology for production is established. The storage can be in gaseous form, but you also have to compromise it to 350 or 700 bars, or you can cool it down to minus 253 degrees, and then you have a liquid form of hydrogen. The energy density is very low, even if you compress it up to 700 bars. It's about 1/10 of the energy density of diesel fuel. The gas stations and the distribution of hydrogen, the infrastructure at all is very, very expensive. And we have only very few gas stations, which are mainly on the main motorways. So not in the land, not in the countryside where usually tractors are operating. The hydrogen costs are also relatively high if they are not funded. The concept tractors and prototypes are available, but they are more because you get good money for research on these. I think there are really good prototypes and good concepts, but so far the problems are higher rather than the way the implementation on the market. Then the battery electric drives, the raw material is electricity, if you want to call it raw material. It is well available because of the grid. Self-supply is possible, especially on the farms. You can make a grid-friendly operation, like you can use the you can charge when there is time of high supply of renewable energy, and you can put it again into the grid if there is a demand on renewable energy in the grid. The efficiency is very high because of the high efficiency of the electric engines. The energy density is about 10 times the volume and 20 times the weight needed compared to diesel fuel for the same operation time. So that means if you have a diesel tank from 500 liters, you need about 5 cubic meters of battery and about 10 tons of battery to carry the same energy to do the same, to have the same range than a diesel fuel, and that probably limits the application in agriculture. But we will talk about that a little bit later as well. The operating costs can be very low because power can be quite very cheap compared to diesel fuel, but the investment of the machinery is partly very high. The charging infrastructure is under construction. Charging stations are getting more and more. You can easily install a charging station with AC in the farm. For DC, is a little bit more expensive, but it's also, I think it's getting cheaper time by time. There's no soil or water contamination, and there are no local exhaust emissions, which can be also a big benefit if you focus on the application in stables, close to animals, on farm. And one big benefit is that it is very quiet, so you have not a big noise. People are really happy when they work on the farm that they have such a technology which is quiet and has no local exhaust emissions. There are quite a few small tractors already available on the markets, which are run exclusively on electric batteries. And there are some in development. There's a lot of small companies, small startup companies who are trying to come onto the market with different types of electric driven tractors, and also loaders or telehandlers, feed mixing wagons, and all the field robot systems are mostly based on electric batteries. So I think the technology is coming more and more into the market, but it starts with the very low power range, at a low power range, because, as I said before, because of the heavy batteries and the big volume the batteries need. If you need more power on the tractor. So now you've seen the overview about these options. Now I want to compare some of these alternative fuels by special properties. One thing I was pointing out just before is the volume ratio and the weight ratio compared to diesel fuel. So on the bottom, you have the different fuels. On the start, as reference, the fossil diesel fuel, and say the unit is 1. It's the red line for the volume, which is green, and the weight, which is blue. And compared to fossil diesel fuel, rapeseed oil fuel, biodiesel, and HVO, all the liquid fuels are similar. So the same energy density, you don't need a bigger tank or something. Also, the refueling infrastructure is almost the same. So you don't need a lot of change. If you look at, and they all can be burned or used in diesel engines. For gasoline engines, you have gasoline, ethanol, CNG or LNG. And here you see, especially CNG, you need 5 times the volume compared to diesel if you want to do the same work, if you want to have the same range with that tractor as you are used with diesel fuel. LNG gets better because it's liquefied, but that's the other problem. You have to cool the tank, and which takes a lot of energy. If you go on fuel cell and electric engine, you have the hydrogen, either 350 bars, 700 bars, or in liquid form. You see, you have at 350 bars about 7 times, 8 times the volume you need compared to diesel. It gets better if you compress it to 700 bar, or if you liquefy it, but you still have 2 or 3 times. You need 3 times the volume compared to diesel fuel. The weight of hydrogen is very low, so that's not a problem at all. If you look at the electricity, you have, I said before, at least 10 times the volume and 20 times the weight of the battery in order to do the same work as you are used with fossil diesel fuel. So that's the big problem with electricity, especially in agricultural applications. And that's even due still so, even if it has a very high efficiency in the engine compared to diesel engine. You still need 10 to 20 times more volume and weight. Let's have a look at the costs. On the top, you have the wholesale prices, the average between 2018 to 21. It's displayed in euro per gigajoule. The next one, you have the wholesale of biodiesel, which is a little bit more expensive because you have to produce this, you have to produce the oil plants, you have to collect the waste, whatever. And then you have different studies. Every point is a different study who worked out prices, but production prices, not the wholesale prices, the production prices for different new fuels. For HVO, we are very close to biodiesel, so HVO is fairly reasonably priced. But if you look at the e-fuels, for example, Fischer-Tropsch diesel, which is the classical e-fuels, which is made by electricity and CO2, you have prices between 23 and 60 euros per gigajoule, which relates about to 80 to 2 euros, 0.8 to 2 euros per liter. And that's just the production cost. So on top, there are taxes and things like that. So everyone has to bear in mind that if we look on new fuels, they will be more expensive as we were used to it. And that's just the fuel costs. Additionally, you have to consider the investment costs of the machinery, especially for battery. They are quite expensive, but also for the refueling and recharging infrastructure. All of these costs have to be considered. Above from that, the maintenance and repair costs and the resale value. So the total cost of ownership, it's hard to calculate because the technology of production is not even in market implemented. It's still more at pilot scale. So it's hard to see costs. That's why the range of the costs of the different studies is also very big, depending on the assumption made. Let's have a look on the potential of these different fuels, which are already, I mean, the fuels which are already available, the production capacities. North America and South America has high capacities for bioethanol and a little bit less for biodiesel. If you look at that. If you look at Europe and Asia, they have the highest production capacity for biodiesel, and then followed by bioethanol. Especially in Europe, we have also some capacities now for HVO diesel, and but all other, say, biomethane or even synthetic fuels, are the production capacities are very, very low so far. And this table, they are all summed up, and you see the different fuels, and you see the various production capacities per year. And when you remember the German consumption of diesel fuel just in agriculture relates to 66 petajoule. So the whole world does not produce much more, or maybe four times the HVO diesel at the moment, as the German agricultural alone uses energy for agriculture machinery. So we have still a very low capacity to produce them. Altogether 4,000 petajoule per year, and what is in plan about 2,000 petajoule. So that's about 6,000 petajoule at all per year. And according to the IEO World Energy Outlook, the demand for 2050 is estimated worldwide between 32,000 and 58,000 petajoule per year. So a lot of effort has to be done to increase biofuel production, synthetic fuel production, and it means we can't focus just on one of these fuels. We have to focus on any of them if we want to reach our goals, our target in terms of climate protection until the year 2045. How can that happen? So expert group were working in a special board, KTBL in Germany, about scenarios for agricultural drives until the year 2030 and 2044. And they evaluated a lot of criteria for all these fuels and for different types of applications in agriculture. They were looking at the raw material potential, the availability of the technology for the provision of energy carriers, the availability of the energy carrier itself on the market, about the properties of the energy carriers, the efficiency and the environmental impact of the drive system, the infrastructure, the refueling process, the availability of the machines on the market, the storage capacities on the vehicle, the investment and operating costs, and if the fuel produces some value creation in the region, and if they are possible to produce them regionally to contribute to self-sufficiency and to food security in a special country. So these are all the criteria. They were taken into account. And this is the result. So what you see is it is divided between light work, medium work, and heavy work applications in agriculture. Light work has tractors or machinery with a typical engine power less than 80 kilowatts, medium work between 40 and 200 kilowatts, and heavy work more than 150 kilowatts. And here you have all the energy carriers we were talking about now. And here's a timeline from 2030 to 2045. 2030 is almost there, so in 5 years, if you have an energy carrier, a fuel, which has no production capacities, it is very unlikely that you will have it 2030 already on the market. So you have to take into account that it takes a while to get the fuel produced and to get the machines for the fuel already produced. So, and have a look at, for example, electricity from battery. The experts think that battery is the one and only important solution for the light work, for the low engine powers. So to explain the color, the dark green is the best, followed by light green, yellow, dark gray, and light gray. The dark green means it is really the preferred option. The green, light green means it is implementable and it's available. It's also suitable. The yellow one, it is partially implementable. The gray one, it could be implemented, but there are better suitable alternatives available. And the gray one means that the suitable energy carriers and corresponding drives are not available. So electricity is the, as I said, the most important energy carrier for the light work and the low engine powers. It might get more and more important even in the medium work, for the medium work. But the experts don't think that for heavy, that they think heavy work cannot be done with electricity out of batteries because of the 10 times volume and 20 times of the weight. Because for example, during harvesting season, the harvester or the tractor is like 24 hours for 2 weeks on the field, and it just takes too much time to reload electricity. The vegetable oil, biodiesel, and HVO diesel, the liquid ones, are still important for the light work and medium work. But for light work, they will phase out because electricity will be the one and only option. But for medium work and for heavy work, all these 3 options might be also a very important energy carrier, very important fuel for the future. For Fischer-Tropsch diesel, which is the 2nd generation, the e-fuel, for example, due to the not existing capacities for production, they think it's only important or only will be implemented on the market near the year 2035, 45, and here also only for heavy work. CNG and LNG is only possible where you have the possibility to refuel it. So you need filling stations. It could be close to biogas plants where you have upgrading plants as well. But due to the expensive installation of refueling systems, it is not everywhere in the countryside where you have only short distances to refuel with CNG and LNG. So it might be a good options in some cases, but overall it will be only, not the big clue. Hydrogen is not well seen in agriculture, maybe in medium work, but the experts don't give a big future on hydrogen for agricultural machinery. Some measures for action I want to point out. How can we reach that? Because there are some hurdles like the price. There are policy options like to create financial incentives. Without that, I don't think it won't work at all. You can do that by energy taxation, by investment support, and so on. Or you can make an obligation for distributing and using machines for renewable drive energy. Obligation is not always a very favorite measure, but still one who could work. And one thing the public sector can do is expanding the role model function. So like our state-owned farms, they can start to implement new technology because the risk is not that big because it's the public sector. So that will be a good way to start the implementation of new fuels. The measures of the agricultural machinery industry and trade is to develop and launch new machines for renewable drive energy. So the hen and egg problem, if there is no demand, the industry will not develop new machinery. And if there are new machinery which are available or suitable for new fuels, there will be no demand from the agricultural sector. Then there could be measures by the fuel producers and traders. They have to do the provision of the renewable fuels, of course, and expanding refueling and recharging infrastructure. And there are various measures by different stakeholders. Of course, research is important, education, dissemination of information, demonstration, and communication, of course, to create the problem awareness that we have to change the fuel-based energy carrier. We have to strengthen the acceptance. We have to show the legal provisions, economics, aims, and strategies. That's all we can do in order to start the transformation process and also to get it to a successful end. All these measures and some more are displayed in these publication, which is just about now translated into English. So you will soon be get it also into English language. So now we are sort of at the end. I will just close with a little summary. What you can take home: electrification of mobile machines in the low and medium power range is feasible and saves up to 1 billion liters of fuel. So half of the fuel demand in German agricultural can be saved by electrification of the low and medium power range. Fuels with high energy density are still necessary, and especially plant oil fuels and biodiesel are reliable, available, and are well-suited energy carriers for the medium and high power range. They can be produced regionally, so they contribute to security of supply. Paraffinic fuels, HVO and e-fuels are also well-suited energy carriers, especially for the existing fleet, but they are expensive and compete with other sectors, especially the aviation sector. So we don't know if they will be available in the future for agricultural sector. Biomethane is a reasonable option as well, but it's only possible when a filling station is nearby. Hydrogen is not yet a preferred option from today's perspective. And to get long-term planning security, you have to make sure that you have stable framework conditions. And for that, it is possible to do the transition of the agricultural drives. And that's all to secure food supply and also to combat climate change. So I have here some further information you can look at. Most of the sources I was talking about are out of these publications. And finally, I really like to thank you for your attendance and attention. And yeah, I hope you have some questions. And yes, thank you very much for your attention.
Thank you, Klaus, for your talk.